Alright, this is exam 2, physics 102, spring 18. Parallel plate capacitor is connected to a battery. Initially has a charge of 12 coulombs. You move to 3 times their original separation. That's the value for D, while the capacitor remains connected to the battery. Since it remains connected to the battery, that means that V is staying constant. What is the value of the charge on the capacitor? Well, let's first think about our capacitance. How does that change? Epsilon naught A over D. This value is getting 3 times bigger, so the capacitance is 1/3 as big. And then I look at Q equals CV. If my capacitance is dropping by a factor of 3, my voltage remains constant. That means my charge is dropping by a factor of 3 too. So it was 12 coulombs, now it's going to be 4 coulombs. Here I have a parallel plate capacitor. There's the area, the distance between them. It has a paper dielectric with that constant, and I want to know how much charge does it hold. There's the voltage. First I need to calculate what is the capacitance. Kappa epsilon naught A over D. That's equal to 2. That's my dielectric constant. 8.85 times 10 to the minus 12, and then the area is 0.02 meters squared divided by 0.0001 meters. And then if I do that, I get 3.54 times 10 to the minus 9. But that is the capacitance. And then if I want to know Q, it's Q equals C times V. That value times 12, and I get 4.24 times 10 to the minus 8. That's in coulombs, but that's going to be 42 times 10 to the minus 9 coulombs, or 42 nanocoulombs. So C is the answer for number 2. If you double the voltage across the plates, how is the stored energy affected? Well, energy is 1/2 CV squared. If I double this, that increases that by a factor of 4. So D is the right answer for number 3. What is the equivalent of this circuit? Well, these two are 1 over 3 plus 1 over 6, and that's equal to 2. And then that's in parallel with this 2 microfarad capacitor, and so that equivalent is 2 plus 2. Let me draw this circuit now. I have a 4 microfarad capacitor in series now with a 4 microfarad capacitor. So those two, the equivalent is 1 over 1/4 plus 1/4. That's equal to 1 over 1/2, or 2 microfarads. So A is the answer for number 4. And then what is the voltage across the 2 microfarad capacitor? Let's go to a different color. So I want to know what is the voltage here. Well, if I have 12 volts here, that means I have 6 volts here and 6 volts here. And if I have 6 volts here, that means I also have 6 volts here because it's in parallel. So I have 6 volts. C is the answer for number 5. And then what is the charge on the 3 microfarad capacitor? Okay, well, between these 2 capacitors, I have 6 volts. Since the equivalent of the 3 and the 6 is 2 microfarads, that means that I have 12 microcoulombs on each of these capacitors. Because the 2 microfarad capacitor has 6 volts across it. Q is equal to CV. And capacitors in series have the same charge, and they have the same charge as their equivalent capacitor. Then I have 12 microcoulombs on each of those. And so if I want to calculate the voltage, which is going to be Q divided by C, it's going to be 12 divided by 3, or 4 volts, and 12 divided by 6, 2 volts. Notice that 4 plus 2 is equal to 6, and then also notice that the smaller capacitor, by a factor of 2, has a voltage that's twice as big. So the answer for that is going to be, oh, actually, let's see, I didn't need the voltage. The answer is going to be 12 microcoulombs. I'm sorry, I gave you a little more than you needed to know. But the charge on both of those is 12 microcoulombs. So number 6 is A. All 3 capacitors are identical. What is the voltage across C1? Well, let's just redraw this. There's C1, and then there is 2C. So I have C and 2C, 12 volts. We saw this before. The smaller capacitor is going to have the bigger voltage, and the bigger capacitor is going to have the smaller voltage. If this doesn't sit well with you, then you can just give them some values. So for example, make C 3 microcoulombs if you want. So then that would have, or microfarads, 3 microfarads and 6 microfarads. And then the equivalent would be 2 microfarads with 12 volts. 2 microfarads, that's going to have 24 microcoulombs. And so I have 24 microcoulombs here and 24 microcoulombs here. And since I have 24 microcoulombs on each of those, I want to know the voltage across C1. 24 microcoulombs on a 3 microfarad is 8 volts. So if you don't like dealing with the variables, you can put in numbers, and I chose numbers here that worked out well. You might not fare so easily, but it's easier just to look at the variables and think about how the voltages are distributed. Okay, each of these capacitors are 2 microfarads. 2, 2, 2, 2, and 2. Realize that this is a parallel circuit with 3 branches like that. There's point A and there's point B. The 2 and the 2 up here, that gives me 1 microfarad. And then likewise down here, 1 microfarad. That's 1 over 2 plus 1 over 2. That's equal to 1. And then the 1 here plus the 2 there plus the 1 there, that's 4 microfarads. In 10 seconds, how much charge goes to a 2 ohm resistor with 10 volts? Well, I is V over R. That's 10 over 2. 10 volts, 2 ohms, 5 amps. And then in this should be 5.0. And then in 10 seconds, Q, is the current times the time. 5 amps times 10 seconds. So it's going to be 50 coulombs. 50 coulombs of charge. Which of these statements is necessarily true? The resistance of a voltmeter is always big. An ammeter is always connected in series. The voltage across an ammeter is small. That's always true because the resistance of the ammeter is very, very small. And the resistance of an ammeter is small. Yes, also true. So all of these are correct. E is right. You might have put B. That was probably the most commonly the most common answer. But the voltage across an ammeter is small because the resistance across an ammeter is small. If resistance is really small, that means that my voltage is going to be small for a reasonable current. Suppose you apply several different voltages, you get a plot like this. What is the resistance? Well, V is equal to IR. But notice I have the y-axis is current and the x-axis is voltage. I want to put this expression in the terms of the equation of a line. And so I'm going to write I is equal to 1 over R times V. That's the same equation. I've just written it so that I is on the y position and V is in the x position for the equation of a line. So my slope is 1 over R. I can also see that my slope is equal to 1/2, right? Rise 15 over run 30. So my slope equals 1/2, and that's equivalent to 1 over R. So R is going to equal, solving that for R, equal to 1/2. In your house, 2 light bulbs operate at 120 volts. One is brighter. Which has the bigger resistance? It's going to be the dimmer bulb. The dimmer bulb because it doesn't allow as many electrons to go through. And you have, as a result, a less bright light bulb, a dimmer bulb. So the dimmer bulb has the bigger resistance. This battery has an EMF of 12. You have a current of 2 amps. And the terminal voltage, we'll just call it delta V. What is the internal resistance of the battery? Remember, my terminal voltage is equal to the EMF minus the current times the internal resistance. So that's going to be 10 is equal to 12 minus 2 times R. And solving for R, I get 1 ohm. And you can think about it, I have 2 volts of potential across that internal resistance because whereas I should be getting 12 volts, I'm really only getting 10 volts. And so I'm losing 2 volts of potential across that internal resistance due to heat or whatever. And with 2 amps, how I get 2 volts is through a 1 ohm resistor. Okay, what's the current here? What's the conventional direction? Conventional direction is how protons flow. And the magnitude of the current is V over R, that's 12 over 3, so it's 4, and it's clockwise. Which has the smallest resistance? Well, This actually is a really low power. This is a high power. The toaster oven gets really hot. It allows a whole bunch of electrons through. That means it has a small resistance. What's the resistance of this device? Well, power is V squared over R, and R then is V squared over P. That's 120 squared over 600. I get 24 ohms. So A is the right answer for number 16. What power is dissipated in a 10 ohm resistor with a potential drop of 3 volts? Well, power is V squared over R. That's 3 volts squared over 10 ohms. 9 over 10 is 0.9 watts. Current 10 amp flows through a wire. What is the resistivity? Well, first, I need to recognize that R is equal to rho L over A. And I need to calculate what is rho. It's going to be RA over L. But in order to do that, I need to first find out what R is. R is equal to V over I from Ohm's law. That's 20 over 10. 20 volts over 10 amps. That's equal to 2 ohms. And so I get 2 ohms. The area is 5 times 10 to the minus 8 meters squared divided by the length. Oh, it's 1 meter. Oh, sorry. Hold on just a second. I'm sorry. So that gives me a resistivity equal to 10 times 10 to the minus 8 ohm meters. That looks like iron. So E is the right answer for number 18. And then number 19, two wires A and B have the same physical dimensions. A and L are both the same. The resistance of wire A, however, is half that of wire B. But resistance is rho L over is rho A over L. I'm sorry, no. Sorry, length over area is rho L over A. So if the resistance, or if the resistivity goes up, the resistance goes up. In fact, the resistance is directly proportional to rho. So whatever relationship I have between the resistances, I will also have between the resistivities. That is that rho A is equal to half of rho B. D is the right answer then for number 19. Okay, if one of these 2 ohm resistors is removed, what happens to the current? Well, these are in parallel, so, if I remove one of them, they act independent of one another, so it's going to stay the same. So number 20 is A. And likewise, let's look at the next one. If I want to know the current, well, I have I as V over R. So I have 2 amps in this one because I have 4 volts. Likewise, I have 4 volts and I have 2 amps here. So I have a total of I have 2 amps going here and 2 amps going here. That means I have to have 4 amps going here. Another way you could do that is to realize that the equivalent resistance of 2 ohm resistors in parallel is 1 ohm. That's 1 over a half plus a half. If I hook that up to a 4-volt battery, then I'm going to have a total of 4 amps. And so that's the answer for this one. 21 is going to be B. Which of these rules for resistors in parallel is correct? They must have the same voltage. Yes, that's correct. They must have the same resistance. Not necessarily. The total voltage is equal to the sum of the voltage. No, that's for series resistors. For resistors in parallel, the equivalent is always less than the smallest resistance. Yes, so 1 and 4. C is the right answer for 22. Which of these in series is correct? They must have the same current. They must have the same voltage? No. The total voltage is equal to the sum of the voltages? Yes, for series. The equivalent is always less than the smallest resistor? No. So 1 and 3 are correct. 3 resistors are in series with a 36-volt battery. What's the potential across the 2 ohm resistor? Listen, people don't like these because you got to draw a picture, but it really helps you to be able to read the words and think about what the circuit looks like. So I have 36 volts, 2 ohms, 4 ohms, and 6 ohms. That is an equivalent. 2 plus 4 plus 6 is 12 ohms, 36 volts. That means I have a current equal to V over R, or 3 amps. So I have 3 amps through each of those resistors in series. If I have 3 amps here, I have 6 volts. So A is the right answer for 24. What's the equivalent resistance? Well, first, this is going to be 6 ohms. Okay, I can go ahead and do this one too. This one is 2 ohms. Let's go ahead and redraw it over here. I have 6 ohms, 2 ohms, 1 ohm, and this is 2 ohms. The 2 and the 1 make 3. The 6 and the 3. So combining these two is going to be 1 over 6 plus 1 over 3. That's equal to 2 ohms. And so I'm left with a circuit that's pretty simple. 2 ohms, 2 ohms, and 12 volts. And a 2 and a 2 in series is equal to 4 ohms. So my equivalent is 4. And then what is the voltage across R5? Let me make a different color here. What is the voltage across this resistor? Well, I'm going to have 6 volts here and 6 volts here. That means 6 volts here, 6 volts here. And then across these two resistors, I also have 6 volts. Whatever the voltage is across this resistor, that's going to be my answer, because it's the equivalent for these two in parallel. So I need to figure out the voltage across that 2 ohm resistor. Now you might be clever and say, well, this has to be 4 and this has to be 2 volts because they have to add up to equal to 6, and the one has to be twice the other because of the way the resistors are proportioned to one another. But let's see how we can get to that. Well, look, I have 6 volts across an equivalent of 3 ohms. That means I have a current of 2 amps. So I have 2 amps here and 2 amps here. And then I can find the voltage because it's I times R. 2 amps times 2 ohms is going to be 4 volts. So that's the answer, is 4 volts for number 26. And then 27, which of these resistors has the largest voltage? We had a similar question that we looked at in class, which has the largest current? And actually the one with the largest current is going to have the largest voltage because, you know, V equals IR. So let's look at it in terms of current. Well, these two will have equal currents. I here will equal I here. These two over here, this one's going to have a little bitty current. But this one, which has a smaller resistance than the one up top, is going to have a bigger current. You're going to get more current diverted through this lower portion of the parallel circuit than you do in the upper portion, because it's the path of least resistance. That's where we get that term. So R5 then has the bigger current. It also has the bigger voltage. So number 27 is D. Let's see, and there will be a throwaway question. Not a throwaway, a speaking of truth question. There's the answers. Notice that a number of these are from OpenStax 4, and actually more than that were very similar to OpenStax questions.